We are starting the different elements connected to the AC source. First, purely resistive circuit, purely resistive, purely resistive circuit, resistive circuit. What is the meaning of the purely resistive circuit mean? If this is the resistance and it is connected to the AC source, okay, this is Vt is equal to what? Say V0 sin omega t. So our motive is to find the current in this circuit, in this resistance, as a function of R. Is it clear or not? So if this is the current IT, right? So this all the voltage is what? The resistance voltage is equal to the Vt. So V0 sin omega t. So what is the voltage across the resistance? This is the VR. So the IT is equal to nothing but VR upon, right? VR upon R. This is V0 sin omega t upon R. So the current in the resistance may be written as V0 upon R into sin omega t, and this V0 upon R, the current as a function of time t is the I0 sin omega t. What does it mean? This I0 is nothing but the V0 upon R, and it is called the peak current, right? This is called the peak current, right? Okay. Now if you see this voltage, what is the phase of this voltage? This is omega t. And what is the phase of this current? Say omega t. Are you getting or not? So if you consider this phase and phase 1 and phase 2, so what is, both are in the same phase. It is clear. It is clear. What is clear? That current and voltage are in same phase. Are in same phase. Both are in same phase. No phase difference between the current and the voltage. Is it clear or not? For example, look, if you draw the graph of the voltage like this, is it clear? 0 to t by 2 to t, right? And the voltage is V0 sin omega t. And what is the current? Current is the same format. It is I0 sin omega t. This is I0 sin omega t. This is IT. Is it clear or not? So they both are moving in the same phase, but the thing is that I0 is very less, little less than the resistance. Understood? Okay, listen one thing. If you have to find the instantaneous power. What is the power? The power, first I will find the instantaneous power. What is the instantaneous power? PT is equal to what? Say Vt into It. Is it clear? So Vt is nothing but V0 sin omega t. And what is the It? You tell. The It is nothing but I0 sin omega t. Right? So V0 I0 into sin square omega t. This is the instantaneous power. Right? But this instantaneous power give no very much information. Right? The average power is useful term. So what is the average power? Average power. How to find the average power? This is the instantaneous power. The average power is nothing but you have to take the average of this function. So V0 I0, and this is the sin square omega t. So now you have to find this average. In the previous class we have found the average of this sin square omega t for one time interval. It is equal to 1 by 2, right? So the average power is nothing but V0 I0 into 1 by 2. This is 1 upon root 2, and I0 by root 2 can be written as, which is equal to what? Vrms into Irms. So the average power is nothing but Vrms into Irms in this resistance, right? Yes. Now we talk about this the phasor diagram. Phasor diagram. The phasor diagram. From this phasor diagram, right? Phasor diagram. Phasor diagram is the way to represent the alternating current and voltage with the help of the vector, because this is the voltage and the current as a function of time t. this is written or graphical representation as a function of time t. But it become very tough when the many elements like resistance, capacitor and resistance are included in the series, right? So to solve this circuit, there is a different type of the mathematics we are going to use with the help of the phasor diagram. What is the phasor diagram? I am telling you. With the help of the phasor diagram, you will represent the instantaneous value of the voltage and current with the help of the rotating vector, right? With the help of rotating vector, suppose this is the vector of the length a, right? Suppose this is the theta and this is the v naught, right? So if this is the v naught and it is rotating in anti-clockwise, so if this is the v naught, right? So this voltage can be represented if this is the vector rotating in anti-clockwise direction, where the theta is equal to omega t and omega is its angular velocity. So if this is v naught cos theta and this is what? V naught sin theta. Is it clear? Theta is equal to what? Omega t. So the instantaneous value of the voltage is given by the vertical component v naught sin theta, and this is v naught sin omega t. This is the vt. Is it clear or not, you tell? So the phasor diagram is the way of representation the instantaneous value with the help of the the arrow. Are you getting or not? So this is the phasor diagram of the voltage. In the same way, the current can also be represented by the vector, right? For purely R circuit, for purely resistive circuit, right? Current and voltage are in same phase. Are in same phase mean if this is the voltage v naught, this is the vector or phasor of the voltage, therefore the current will be in the same phase. Are you getting or not? For example, if this is the theta, so it is, this is the vertical component I naught sin theta, that is sin omega t, and this is the vertical component, this is the I naught sin omega, v naught sin omega t. Are you getting or not? So for resistance, current and voltage are in the same phase. Are you getting? That is, if this is the current vector, this is the voltage vector, they are rotating in the same direction, right? We can do some question, right? For example, if there is a bulb, right, and the rating of the bulb is 200 watt and 220 volt, right? Whenever the rating is given, this is the power is always the average power, and the voltage is what? Say RMS voltage. Is it clear or not? That is the thing. So you have to, this is the bulb whose power rating is this, all right? So what you have to find? You have to find first the resistance of the bulb, resistance R. Second thing, you have to find the IRMS value. Are you getting or not? So how to find? Whenever the P average and the RMS value is given, so P is equal to what? V square upon R. So resistance will be found with the help of the V square RMS and the P average. Is it clear or not? So resistance VRMS is what? Say 220 square upon the average power is 200 watt. So this the resistance is equal to what? 200 into 220 into 220. 0 will cancel out. 11 into 20. So what is the resistance? 2242. This is 242 ohm is the correct answer. Is it clear or not? This is the resistance. 240 ohm. 242 ohm is the resistance. This is the first part. And how to find the IRMS value? You tell me. The IRMS is nothing but VRMS divided by R. What is the VRMS value? It is 220 upon resistance. What is the resistance value? It is 11 into 22 I am putting. Not 240 because it is multiplied. Then it is 10 upon 11 ohm. Sorry, ampere. So this is the IRMS value of the current in this resistance. Is it clear? Yes. Copy this. The next element is what? Okay, so what is the next element? The purely inductive circuit. Inductive circuit, right? What is the purely inductor circuit mean? If only the inductor is applied to the V naught sine omega t in this case. This is the VT, right? This is the L. This is the IT you have to find. Is it clear or not? That is the thing. So, inductor. So, this V source, the inductor is nothing but equal to the VT because all the voltage supplies is applied across the inductor. The V naught sine omega t it is, and this is VL is equal to L di upon dt. Is it clear or not? So, L into di is equal to V naught into sine omega t into dt. Is it clear or not? So, if you apply the integration sine omega t dt, the integration of Li is V naught, the integration is minus cos omega t upon omega. Do you know the integration of sine omega t is minus cos omega t upon omega, Sanjay? Yes. So the I is equal to what? V naught upon omega L, and this is minus cos omega t. This may be right modify, and this is sine omega t minus pi by 2, it may be written. So this is the current. Current in the circuit V naught upon omega L. This omega L is assumed to be XL. This is nothing but inductive reactance, right? First copy this. The inductive reactance. What is XL? What is XL? XL is nothing but inductive reactance. Inductive reactance. What is the meaning of the inductive reactance, you tell? It is the resistance of the inductor offered by the current. I will explain this. First, the IT is equal to what? Say V naught upon XL is equal to sine omega t minus pi by 2. It may be written as the peak current sine omega t minus pi by 2 is equal to IT. Is it clear or not? So this is the current and this is the voltage. All right. So you tell me, if you consider this the voltage and this the current in the inductor, so the what is the phase? Its phase is omega t, and its phase is what? Omega t minus pi by 2. Are you getting? So this is the phase. So current phase is lagging to the voltage, or voltage phase is leading by the phase pi by 2. There it is clear. It is clear. What is clear? That in inductor, current is lagging. Current is lagging, right? Or we can say the voltage is leading by phase pi by 2. Is it clear or not? The graph. What is the graph of the V naught? If you make the graph of the VT, so graph is like this. This is the VT is equal to what? V naught sine omega t. And what is the graph of I naught sine omega t? Can you make? This is the at t is equal to 0. The current is minus I naught. Right? It is like this. This is the t by 2. So this is the VT graph. This is the I naught sine omega t graph. This is the IT. Are you getting? That is the thing. Is it clear? What does it mean? At t by 4, this is t0. This is equal to what? So it is equal to minus I naught, and this is equal to I naught. Right? So this is equal to V naught and minus V naught. Are you getting or not? Right? So current is lagging. The current is lagging in the inductor by phase pi by 2. When the voltage is maximum in the inductor, the current is what? 0. Are you getting? When the current is negative, then the voltage is 0. It means the voltage is always lead by phase pi by 2. If you want to make the phasor diagram, right? What is the phasor representation? If you consider the voltage this is the voltage, suppose, and the current is 90-degree lag behind. It is lagging. The current in the inductor is what? Lagging by phase 90-degree. Are you getting or not? This is the current in the inductor, right? Copy this. Okay, listen. You can make the more phasor diagrams, right? Suppose this is the L, this is the IL, right? So you can think that the voltage always lead to the current like this. After some time it become like this. So if this is the VL, the current is rotating, lagging behind the voltage by 90-degree. Current is back, and the in the forward it is the inductor, right? You may make this figure also. Suppose this is the IL, so the voltage will be rotating like this. It is 90-degree. Getting or not? There may be some other figures. Suppose this is the VL, right? So the IL will be lag behind 90-degree. So there may be so many figures of the phasor representation, but the current should be always less than, lagging behind the voltage. The voltage should be leading by phase 90-degree. Do you understand this or not? So this is the phasor representation. Now I will discuss the power. The power in the inductor. The instantaneous power I will discuss first. What is the instantaneous power? Vt into it. Is it clear? So what is the Vt? The Vt is nothing but V naught sine omega t. And it is what? Say I naught. Wait for 1 minute. It is sine omega t minus pi by 2. You have to write. Please make it correct. This is I naught sine omega t minus pi by 2 is the current. And the current is I naught sine omega t minus pi by 2, which may be written as V naught into I naught sine omega t, and it may be written as minus cos omega t. If you multiply by 2 in the numerator and the denominator, this minus comes here, 2 sine omega t into cos omega t, right? This minus sign comes outside. So this is the instantaneous power, may be written as Pt is equal to V minus V naught I naught upon 2. This is sine omega t. Listen, first we have to find the instantaneous power. Although the instantaneous power is not a useful term, it does not give any very much information. We have to find the average power. To find the average power, we have to take the average of this function and the V naught I naught upon 2 and the average of sine 2 omega t. So if you find the average of this, sine omega 2 average is 0. I told you in the very first day, right? So the average power is what? 0 in the inductor. In this inductor, the average power is 0. What does it mean? It means for the half rotation, half cycle, it charges the inductor from the one direction, right? For the positive cycle, the current goes in this way, and for the next half cycle, the current goes in this way. So it continuously charging, and then the power is again transferred back to the AC power source. Do you understand or not? Therefore, no ideal inductor, that is ideal inductor does not take any power, does not lose any power, does not lose any power. Is it clear or not? Now we will discuss the instantaneous. We have discussed the instantaneous power. The inductive reactance I will discuss. Right now, write the heading: inductive reactance. Inductive reactance. Inductive reactance. What is the inductive reactance? It is L. What is inductive reactance definition? It is the resistance. It is the resistance in the path of AC current offered by inductor. Is it clear or not? Offered by inductor. And what is XL? It is omega. What is the unit? SI unit? of resistance. This is the resistance of the inductor. If this is the inductor, the inductance is L. All right. So what is its resistance? Its resistance is omega into L, and SI unit is ohm. Do you understand or not? The XL depends upon the frequency. If this is the inductor connected to the source, and the frequency is what? Omega, right? So XL is directly proportional to the frequency of this alternating source, right? So this is the XL and the frequency. The XL is proportional to frequency. As the frequency is increasing, the resistance is also increasing. All right. So this is the inductive reactance, which is proportional to the frequency. If the frequency is 0, right? What is the for DC source? For DC source. What is the frequency for the DC source? That is the frequency is 0. If the inductor is applied to the DC source like this, plus minus L, right? What is the frequency? Is 0. So XL is what? So XL is what? 0. That is inductor act as a wire. Is it clear or not? For if the DC power supply is applied, so the frequency is 0, it acts as a wire, simple wire. Are you getting or not? This is the simple wire. If DC power source is applied, as the frequency is increasing, the inductive reactance is increasing. Listen one thing, inductive reactance means the resistance of the inductor. So if you consider a simple resistance, this is the 50 ohm, it is fixed, it does not depend upon the frequency of the source. But this is the inductor, its resistance also depends upon the source we are using. Are you getting or not? That is for capacitor. The third is the capacitor, right? The capacitor. When a capacitor is connected to the AC source like this, is it clear or not? This is V naught sine omega t, and this is Vt, the capacitor. So the way our work is to find the current in this capacitor. Are you getting or not? So how to find the capacitor? The Vc is nothing but equal to the total voltage is applied. This source voltage is connected to the voltage capacitor V naught sine omega t, right? And Q is equal to Cv, right? The Q is equal to what? C into Vc. This is C, V naught sine omega t. Listen one thing, because the voltage is time variable, so voltage of capacitor is also the time variable. So the charge on the capacitor is also the time variable. What is the charge is coming from the alternating source is variable with the time. So if you want to find the current as a function of time t, so you have to find dq upon dt. This is C V naught, right? D upon dt sine omega t. Is it clear or not? So this is the current IT is equal to C V naught d upon dt sine omega t. What is the differentiation of this? This is omega into cos omega t. So this is V naught and 1 upon omega c is equal to cos omega t. This is the current as a function of time t. Is it clear or not? Right? Listen, current is always voltage divided by resistance. Voltage divided by resistance. So this is the current in the capacitor, which may be written as like this. IT is equal to what? Say V naught upon XC into cos omega t. Do you understand this thing? I'm also writing again. Listen, this IT, where what is XC? Where what is XC, you tell? The XC is nothing but the resistance of the capacitor, which is called the capacitive reactance. Capacitive reactance. Fine. X is equal to what? 1 upon omega c. And I will discuss this later. But this is the peak current V naught upon XC. This is the peak current. So the current may be written as I naught cos omega t, which may be written as sine omega t plus pi by 2. Is it clear or not? So this is the current sine omega t plus pi by 2. What conclusion you can draw from this expression of the voltage applied to the capacitor, and this is the expression for the current found in the capacitor? You will see its phase is omega t and its phase is what? Omega t plus pi by 2. What conclusion you can draw? In this case, the voltage is lagging, its phase is leading. That is, it is clear. Current in the capacitor, current in the capacitor, current in the capacitor is leading, is leading by phase pi by 2. Or you can say, what can you say? Voltage is lagging by phase pi by 2, right? That is the thing. So if you want to draw the time domain graph of these two functions, v naught sine omega t, it is vt is equal to v naught sine omega t. And what about the current? Current is I naught sine omega t plus pi by 2. Mean at t is equal to 0, the current is what? The voltage at t is equal to 0, voltage is 0, you put over here. But at t is equal to 0, the voltage is the current is the maximum value I naught. Then it will reduce to 0, it will reduce to, and it will reduce to this. Is it clear or not? Like this. Are you getting? So this is t by 2 and this is t. Are you getting or not? So the current is lagging in this case. Now, if you want to make the phasor diagram, phasor, it is very important. What is the phasor diagram? Right, listen. The current is lagging mean, if this is the IL, the voltage is lagging behind. There may be different photograph or the different phasor diagram like this, like this, like this. So this is the current is always 90-degree lagging, 90-degree leading. Sometime it may happen if it is IL, it is VL, 90-degree leading. Sometime it may happen this is the IL, this is the VL. Are you getting? 90-degree leading. Sometime it may happen this is IL, this is VL, 90-degree leading. Are you getting or not? Sometime it may happen this is VL and this is IL, 90-degree leading. So any of these is the valid phasor diagram for current and voltage in the inductor. It is capacitor. It is capacitor. It is capacitor, not inductor. It is capacitor. It is capacitor. 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 Sorry. So in capacitor, voltage is always lagging by phase pi by 2. Okay, so the instantaneous power. Instantaneous power. What is the instantaneous power, you tell? The PT is nothing but Vt into It in the capacitor. It is V naught sine omega t always. But here the current is sine omega t plus pi by 2. Is it clear or not? So this is V naught I naught sine omega t and this is equal to cos omega t, right? So this is the instantaneous power, but it is useless term. So this instantaneous power can be written as V naught I naught by 2 and it is multiplied by 2 sine omega t into cos omega t. Is it clear or not? That is the thing. V naught I naught by 2 sine 2 omega t. But it is useless term. What we have to find? The average power. The average we have to take like this, V naught I naught sine 2 omega t. What is the average value? It is 0. So what is the P average? It is 0. What does it mean? The same meaning as in case of inductor. For half cycle, the capacitor is charged from the one side. For the next half cycle, right, the capacitor is charged from the other side. In this case, right, in this case, in the next cycle, the current will be given in this direction. In this case, the current is going like this. So in the next half cycle, resend the power to the source, and again in the next half cycle, right, it resend its power to the source. So net power loss by the capacitor is 0. That is, net power loss by capacitor is 0. By capacitor is 0. Do you understand this or not, Utah? What is the inductive reactance? Now, oh sorry, capacitive reactance. It is capacitive reactance. Capacitive reactance. The XC. It is nothing but the resistance offered by the capacitor in the path of the current, AC current. Resistance offered by capacitor in the path of AC current. AC current. Is it clear or not? The Xc is equal to what? 1 upon omega C is equal to 1 upon 2 pi F into C. Right? So Xc is proportional to F. Are you getting or not? If we draw the graph between the Xc and like this is the function Xc, and inversely as the frequency is 0 for the DC source, suppose this is the capacitor, right, and an AC source is applied. So the resistance of the capacitor, which is nothing but the capacitive reactance, does not depends upon only the C, rather it depends upon the frequency of the source also. As the frequency is increasing, right, the capacitive reactance is decreasing. You understand? For DC source, the frequency is 0. If you apply the capacitor to the DC source, right, the frequency is 0. What will be the Xc? Say 1 upon 0 is equal to infinite. What does it mean? For the DC source, no current can flow through this, the 0. It offers the infinite resistance. That is, capacitor offer infinite resistance in the path of DC supply, DC current. Is it clear or not? So now we will discuss series LR circuit connected to the AC power supply. If this is inductor, this is resistance, and it is connected to the AC power supply, and this is V0 sine omega t is equal to V. If this is L, this is R. Are you getting or not? You tell me. If it is L, it is R. So the current goes in the IT. All right. If this is the VL, this is the VR. Right. So when you apply the KVL, VT minus VL minus VR is equal to 0. Is it clear or not? VT, what is L? VL is minus L. VT is equal to what? VL plus VR. What is the inductor voltage if current is variable? So L di upon dt is equal to IR VT. So L di upon dt plus I into R is equal to VT is equal to V0 sine omega t. Do you understand or not? This is the thing. This is the differential equation, the first order differential equation it is, right? This is the first order differential equation. Our motive is we have the V0 sine omega t is the voltage, and we want to find the current in the circuit. So using solving this differential equation, we can find the current in the circuit, but we will not proceed further, right? It will be the typical method for us in further calculation, right? So although KVL wise, in the time domain it is true result, but for finding out the current in this LR circuit, we will use the phasor analysis method. Is it okay, right? Now how to solve this circuit with the help of this right phasor diagram. So can you make the phasor diagram? Yes, using phasor diagram, using phasor diagram, right? Using phasor diagram. The current, this is series LR circuit. In this case, the current is common. The if the current is common in the, for the resistance, current and voltage are in the same phase, and the inductor voltage is leading by 90° with the total current. Are you getting or not, you tell? So if this is the VR VL, what is the net voltage? The net voltage is this at angle theta or phi, you can see, right? So net voltage is equal to what? VL square plus VR square, the square root. Are you getting? This is the square, right? So what is the VL? VL is equal to what? IL into XL. What is VIR? I into R. Because what is the current in the circuit? We can assume the IRMS value is the I in the circuit. Although this is the instantaneous value, the IRMS value is I. If you take I common and V upon I. So total voltage divided by total current is the impedance. XL square plus R square. This is the impedance. Impedance of, what is that? Impedance of LR circuit. Is it clear or not? LR circuit. Now you can also make with the impedance triangle. Yes, listen, this is the V upon I is equal to Z. Total voltage divided by total current, it is assumed to be Z. So V is equal to what? I into Z. VRMS is equal to IRMS into Z. Sometime this is the relation. This V and I is nothing but the VRMS. But sometime V naught by root 2 is equal to I naught by root 2 into Z. So V naught is equal to I naught into Z. So Z may be written as V naught upon I naught also. So the impedance is the ratio of V naught I naught or ratio of V and I or VRMS upon IRMS. VRMS upon IRMS is also the ratio, this ratio is also equal to Z. So if we found from this the total voltage and this is the total current and the phase is phi. What is phi? From here we can find the phi. What is phi? Listen one thing. The voltage is V and the current is I, the phase is phi. The voltage is leading or current is lagging by phase phi. What is phi? Phi is the phase between the total voltage and the total current. It can be found with the help of the impedance triangle, right? Impedance triangle. What is the impedance triangle? Listen, this is VR, this is VL, the total voltage is V, this is phi. VL is equal to what? Say I into XL. VR is equal to what? I into R. Total voltage is equal to I into Z. So it may be written as XL, R, and this is the Z. This triangle is called the impedance triangle. Is it clear or not? So from here, the tan phi is nothing but XL upon R is equal to omega L upon R is equal to tan phi. Right? So in this way, the phi can be written as tan inverse omega L upon R. All right. This is the value of the phi. Now, here it is clear. The current is what? Current is lagging. Current is lagging by phase phi. Is it clear or not? Current is lagging by phase phi. And what is the phase? Phi. Between the total voltage and the total current is this. So, therefore, what the current in the circuit, in this circuit may be written as I naught sine omega t minus phi. What is I naught? I naught is the peak current, which may be written as V naught upon Z. And this is the sine omega t minus phi. So the current as a function of time t, we have found V naught upon Z. Z is root over XL square plus R square sin omega t minus, what is the phi? It is tan inverse omega L upon R. So this is the current in the LR circuit.